Good morning, guys. How's everyone doing today? Go ahead and let me know if you're here in the chat. Good morning, Rachel. Looks like Hunter might be here too. Looks like he's checking out the calendar, so I'm guessing Hunter's here. There he is. Good morning. There's one more. My prediction's correct. It's probably Liberty. Cole, whereabouts are unknown. How was your guys' weekend? Everyone have a good weekend? Anyone have anything interesting to share? Do anything fun? Always like to hear stuff like that. Weekend was all right, just all right. Okay, it was actually really fun. My family did a lot of bonding. We did a puzzle. There you go, Rachel. I think that's what this whole situation's about, is being able to enjoy your family, because that's who you're stuck with for the most part. I actually it's funny you said that, because I went to my parents, and my brother came over and his girlfriend came over, and we all kind of hung out, which was fun. But we did like a puzzle too, and it wasn't like one that you put like pieces. Yeah, I mean you put the pieces in, but it wasn't one where you like look at the picture and you try to just like replicate it. It was like a trick puzzle. You had to like try to put it together, but it was like only like, I don't remember how many pieces, like 12 pieces, but it's really hard. You had to like kind of match them all up. So that's what I did, but it was entertaining. You said we zoomed some of my extended family. That's cool. It's cool that people are doing that, like trying to zoom. Like I've been zooming a lot of my friends, which has been, it's not ideal, but it's a good way to still stay in touch and have that personal conversation without being together, which I think is really nice. That sounds tough. It was like, yeah, it's hard for me to explain. Wish I had like a picture of it, but it was pretty difficult. And at first, I took it as like, oh, I can like think my way through this. Man, I always do that. I don't know if anyone can see me right now. I accidentally logged out of my. I don't know if anyone. One second, guys. I don't know if anyone's like, if you're able to hear what I'm saying still or not, because I think I'm still technically live, but I accidentally went backwards on my YouTube. This is a good time now if you guys want to get up your 2018 FRQ. Now is a good time to do that. Go ahead, get that up, get your notes out. Let me see if I can figure out how to get back to my screen I was at. There we go. Okay. All right. think I'm back. Guess I'll find out if anyone answers that. Okay, cool. Yeah, anyways, that was pretty much, that's what I did this weekend. That's what kept me busy, just talking to some friends over Zoom, and got to see my parents and my dog, which is always great. Oh, and the NFL draft, of course. That was always something I look forward to. So the Browns got some pretty good picks. Very, very happy with that. So now I got something to look forward to. I don't know how the season's going to look. It might be empty stadiums being played, or like half a stadium allowed, or whatever they may do. It's going to be a little bit different probably, but I'm still excited for it. So just so you guys know, let me go to my screen here. This is what we got planned for this week, as I'm sure you've seen already. Same kind of outline. I mean, if you guys haven't realized, we got all of this week, all of the next week, and then one more week, and then that Friday, I believe, is your AP test, so the 12th. So in terms of streams, you guys have 6 more streams officially. So you had 6 more streams until the AP test. That's without Fridays. So those are just the Monday, Wednesday streams you guys will have. And we're gonna keep this pace going. So one thing I want to say for you 3 who are in here is make sure your emails are up to date in College Board. So whatever email you guys find is on file for College Board, make sure you guys go in, check your profile, make sure that you're going to get your emails sent to the one that you check regularly, which I would assume would be all of your SailorNets. Just double check that real quick, because if that's not the right email or some issues with that, then all of your AP tests you're going to have a hard time with. So I'm sure other teachers probably told you this by now, but just make sure you guys go in and check that if you haven't already. Make sure that if you have any issues with uploading, so if you guys have found yourselves, from what I've been looking at, your assignments, it doesn't look like you guys are having any issues. But if for some reason you face any sort of issues when you're uploading assignments on College Board, let me know now. So then that way we can kind of think of a solution for when the real thing happens. There's been a lot of resources. I guess I think sometime this week, I can't remember what day it was supposed to be, but sometime this week, AP is supposed to give us teachers like a better outline of what it's going to look like the actual day of the test. So I think I'm going to get more information. All of your AP teachers are going to get more information on how it's being administered, what you guys have to do personally to get logged in. And I think there's going to be a way to practice that, so you're not the first time you're doing all this isn't the day of the AP test. So we can run through that, and you guys can get comfortable with however they have that set up. So I'm going to give you more information on that when I get it. Make sure you're checking your emails from College Board. They might be sending stuff to students, some stuff that might update you guys. The YouTube page is still going for them, so if you guys want that extra practice, or there's a concept you really want to review, but we're not doing them in class, and you would like to look at it again, AP has a bunch of videos for BC, so you guys can look back, especially from Unit 10. So series, if series is giving you a little bit of a problem, Unit 10, they've had a lot of videos uploaded to YouTube, so you can check that out for the College Board. And so I guess the overall what I'm getting at is this week we're going to continue with the practice. We're going to do 2018 international practice and 2019 international practice. So you guys will do 18 will be today. You'll finish that up for today's during class, and then for homework. 2019 we won't get completely done this week. We'll finish early next week. All right. So that's the outline. You guys can go ahead and get started then. If you have any questions as you go, same old, let me know. I will be here, so just keep me updated as you go, and go ahead and get started. All right. Rachel, for part B of 4, let me open up the assignment real quick. Okay, so for part B of 4, would x equals 0, would there be no x coordinates? Okay, so would x be, or would there be no x? Because if you set the second derivative equal to 0, you get x equals 0, but also that would be 0 over 0 if you plugged it back in. Yeah, so Rachel, you're correct. It would be at 0, but it wouldn't give you 0 over 0 if you plugged it back in. There shouldn't be, because you're given your original g prime is 2 times the absolute value of x, right? So if you're taking a derivative or an antiderivative of that, however, whichever way you go, there's going to be no fractions. So you're never going to have like anything that's indeterminate like that. But you are correct. Yeah, it would be x equals 0, 0 point of inflection. Okay. Yeah, Rachel, what did you put down what you had for your second derivative? Oh, okay. Yeah, so that'll explain it. So I think maybe let's look at this a little bit easier. So I'll show you on mine real quick. All right, so this is for 2018 Q. This is 4B. Actually, no, sorry, 4A. All right, so the way I looked at it was, let's first figure out how can we express this. So absolute values, like what are they, right? Absolute values are just saying that it could be positive or negative. It's just giving you the opportunity to be a positive or negative sign. All right, and that means obviously the absolute value makes it positive, makes a negative number positive, but that doesn't mean that the negative numbers aren't a part of our solution. Okay, so we want to somehow, how can I rewrite what g prime of x is? And we do that, we rewrite absolute values as piecewise functions. So your first option is always the positive version. So 2, let me actually redo that. I'll put the one on the bottom just so it makes sense. So we still, no matter what, right, if x is greater than 0, this is always just going to be positive 2x. Okay, we know that. But if x is less than 0, it's going to be negative 1 times 2x. So that gives you your entire solution set to two absolute value of x. Remember, it's absolute values are piecewise functions where it's split up into two separate functions. So if like we were to imagine this, the graph of g prime of x, this isn't perfect, but it's going to look something like that. So from x is less than 0, that's my linear function negative 2x, and from greater than, my positive linear function positive 2x. That's what the graph of two absolute value of x would look like. So based off of this original function, I think you should be fine going from there, right? Because if we're getting a derivative, so g double prime of x, that's going to be equal to the piecewise. The derivative of negative 2x is just negative 2, and the derivative of positive 2x is positive 2. So maybe that's the route you took or not, but hopefully that makes sense with the piecewise functions. So just to clarify, guys, if hopefully this cleared things up, but based off of this, then when you're checking for concavity, or should I say when you're checking for any point of inflection, it's when concavity changes. Well, the second derivative gives us concavity. Less than 0, it's negative 2. Greater than 0, it's positive 2. So that means it had to change concavity somewhere in between less than 0 and greater than 0, and the only spot that is at x equals 0. So your point of inflection would be at x equals 0 still, Rachel. Yeah, no problem. Just want to make sure you're okay with that. All right. Liberty said she's ready to go over question 4. So if you guys are all ready to do that, we can do that. Rachel is too. All right. Hunter, how about you? How are you doing? Yep. Okay. Let's go to question 4 then. So I did most of the first part, so you guys can see on my paper. G prime was that piecewise. So the derivative is you're given is that. And we also needed to find just what g of x was. So you would take an antiderivative of g prime, which would be negative x squared and positive x squared. One thing you can add, because this is a piece of information they give us, is in between. I know I kind of messed this up, but in between you can also say 0 for x equals 0. Because they give us that in the actual question. It says let g be a function that satisfies g of 0 equals 0. So one other thing you'd want to mention in that piecewise is that fact. Even though it's given to us, so it's a little bit redundant, but either way, you're right. Part B, like I said before, you would have your answer would be 0, so your point of inflection is at 0. Reason being is because that's when concavity changes. So when you're explaining your reasoning, you got to say, well, the point of inflection occurs when concavity changes, which means when the second derivative changes sign. You look at where the second derivative changes sign, it's at x equals 0. Okay, for part C, you're using Euler's method. And you should end up getting 2 plus 2 times the square root of 17 is your approximation for h of 4. Again, that's 2 plus 2 times the square root of 17. All right, and then part D, you're going to have to use integration by parts. And when you do that, use integration by parts and evaluate at those bounds, you get negative 2 minus pi. Again, you get negative 2 minus pi. All right, so how do we do with that, people? Nice, good job, Rachel. I know we love integration by parts, so I was pretty excited to see that was in this question. Makes me think of Liberty. That's that poster he gave me. Well, yeah, it was like a printout. When you do integration by parts multiple times, it's just one thing you swore to destroy. This one was good though. Hunter, just pretty good? That doesn't sound convincing to me. If you guys have any questions, obviously, feel free to ask. The homework tonight, by the way, is just number 6. So even if you guys have about 15 minutes, even if you don't get number 5 done, number 6 is really quick. So your homework, if you guys don't get 5 done, just finish 5 and 6 for homework. Liberty said I'm good. All right. So guys, there's about 5 minutes left. I'd like to figure out where you guys at right now, BC, and then I'll go over at least your answers up to the point you're at collectively, or at least like around where you're at. So then that way you can for number 5, if your process is good and everything, if you're doing all right with it. So just let me know what number you guys at, or what part of number 5 are you guys at. Rachel almost done with part C. Okay. So Rachel's through at least B. Hunter through, okay, so Hunter's through C. Or he's on C, so you're at least through B, Hunter. Okay, perfect. So I'm going to give you guys A, B, and then I'll actually give you C too, so you can write down your answer, and then you know what you have to get to. If you guys are almost done with it. All right, so 5A, you should have gotten approximately 6 grams. So your tangent line should have been y equals 10 minus 2t. At t equals 2, you get y is approximately 6 grams. For part B, you wanted to notice that the derivative is negative 0.02y squared. That's always going to be less than 0. Because since y is being squared, that'll always be positive. So you always have a negative number times a positive number, which is always negative. So because that statement is always going to be less than 0, f is going to be always non-increasing. So the derivative tells you if it's decreasing or increasing. Since it's always negative, that means the function was originally always decreasing. If you guys look at the graph they gave us, there's a portion of it that's increasing. So by that reasoning, there's no way that f could resemble, or our f could resemble the graph they give us. Hopefully I explained that thoroughly enough. Let me know if that was confusing or you need me to reiterate B. And then part C, you guys should have gotten your C value was negative 1/10 or negative 0.1, however you wrote it. And then your y, or your actual expression, should have been y equals 50 divided by t plus 5. Or if you wrote like a complex fraction, you would have gotten y equals 1 divided by the quantity 0.02t plus 1/10. Again, y equals 1 divided by 0.02t plus 1/10. And part D, just so you know, your answer should be increasing rate. And I'll let you guys work on trying to find why that is. All right, so 2018 FRQ for Calculus BC people. We're going to finish that up. Well, you're going to finish that up for homework. And then on Wednesday, we can talk about any questions you guys have. So if you have a question on 5C or D and any part of 6, then we'll go over that on Wednesday. So that'll be the first thing we do. Okay, and if there's nothing you guys have, BC people, you are good to go. I appreciate you guys stopping by. Hopefully all this review, I mean, you guys have been doing this for a while now, but I'm hoping this helps you out, gets you ready for the AP test, and you're starting to feel more and more confident every assignment we do. That's what I'm hoping for. You too, Rachel. Have a great day. See you, Liberty. Have a great day. Yeah, you too, Hunter. Appreciate it. If anyone talks to Cole, specifically you, Hunter, tell him I said hi. Hope he's doing good. How's it going, Calculus AB? How's everyone doing? Good morning, good morning, or good morning. Happy Monday. Or not so happy Monday, however you want to look at it. How are we doing with numbers? 9 people? Okay. I like the looks of that. I see people are already smashing the like, which is great. I don't even have to ask you anymore. Hopefully it's like, what's that one experiment in psychology? Pavlov's like dogs. Is that what it's called? Is it Pavlov? Can't remember. But he basically trains the dogs, right? And anytime they hear, I think anytime they hear like a buzzer, they want a treat or something. They know they're gonna get food or something like that. Can't remember exactly how it goes, but that's basically how I'm viewing this. Is I've trained you, so anytime you log into my stream, it's just like you just subconsciously just know to click the like button. That's the goal. And as usual, I'll get started in a couple minutes here. Go ahead, guys, and you guys can get your Unit 7 FRQ Part A out and open. That's where we'll start. What's good, Digidio? Brandon, I don't know if I congratulated you yet, but I heard you made a decision for college. You wanted to keep wrestling. I can't remember where it was. Was it Heidelberg? Can't remember where your dad said you were gonna wrestle at. But congratulations, that's awesome to hear. Not much, just hanging there. Yeah. I feel really bad for you guys, especially you seniors. Yeah, it is. Okay, awesome, Brandon. That's really cool. Congratulations. You're welcome. Hope all you seniors in here, you guys are doing all right. I know this whole situation's really sad. And I hope that you guys are finding ways to I guess cope with the situation. All right, so a couple more minutes to see who comes in. Looks like I got 10 people now, which is about the normal number I'm used to. Just means I'm doing good. Okay. So let's get started here. Let me put my screen up. All right. Well, hope you guys all had a great weekend. Number one. Go ahead and type in the chat while I'm talking. If you guys did anything fun, if you had a good weekend, what your game plan was this weekend. I hope it was all good. Hopefully, you're trying to find you're getting some good habits. Maybe finding some fun things to do. During the quarantine. Maybe it's a hobby. Maybe it's talking to friends or playing games over the phone. Whatever it may be. Hopefully, you guys are staying busy and still communicating with everyone. My weekend was all right. I got to go home and see my parents and my brother, which was cool. My mom made dinner, which is delicious. Always great when I get to eat her food. We did this like cool little puzzle thing that was really entertaining because we thought it was gonna be really easy. It was like a 14-piece puzzle, like not very many pieces, but that wasn't the point. The point wasn't like look at a picture and replicate it. It was like a puzzle. So it took way longer than we thought it was going to take. It was way harder than we thought, and it was funny because like me and my brother were trying to my brother and I, for those of you who are picky, we were trying to like reason our way through it, and we were like really thinking about it and like thinking of strategies to solve it. And like at one point I got frustrated and I was like, this is stupid. And I just started like matching pieces up and just flying through it, and then I got it through. I got the answer right. And I was like, of course. My thought process of like trying to reason my way through it wasn't as smart as I thought it was gonna be. So yeah, that's what I did, and then I also zoomed with some friends, which was fun. It's always good to stay in contact with them. It looks like maybe, I don't know, knock on wood, hopefully this, like today or tomorrow, sometime really soon, Governor DeWine's going to come out and say, give us a little more update, because as you guys I'm sure know, May 1st is supposed to be like the first step of kind of getting back to normal to an extent. Obviously, school is never going to be back to normal for this year, which stinks. But in terms of just your everyday life, it looks like May 1st, things might be open. I think certain businesses are going to open up again. At the very least, they're going to find ways to make it work, even if it's not normal openings. I mean, they're still going to be cautious about it. But, you guys, I'm sure will hear about it, but I recommend keep an eye and ear out for updates on that. You'll hear, I think, today or tomorrow. And then Friday, they might lift the stay-at-home situation. I don't know. Like they might say, okay, you guys aren't completely having to quarantine. Maybe you can go out and like go to the grocery store more regularly. Go see, rather than just being with your family, maybe you'll be able to go see friends and stuff in small groups. So I don't know. I'm not telling you to do that. I'm saying whatever governor comes out and says, just keep an eye out. Just be optimistic. That's what I'm trying to be. Hopefully we get some good news this week, which is the bright side of things. Even though school is not going to resume as normal, we're still going to, the rest of the world in our lives might get back to at least a sense of normalcy coming up. What else do I want to say? Okay, so that's number one, agenda. In terms of your schedule, so you guys can see today we're doing Unit 7. So we're going to review Part A, which was just one question, A through C. And then we'll work on Unit 7, Part B as a class. I'll do my normal thing. I'll go through that step by step. See how you guys do on that, how you're feeling about that. Brandon says, I think I'm going to play it safe for a bit. Yeah, absolutely, Brandon. That's what I'm saying. Like, regardless of what he says, I'm sure there's going to be a lot of stipulations. It's going to be more so like, hey, we're going to stick to like the script we've been following. Like if you're going to go out, wear a mask. Don't go out unless it's entirely necessary. If like you need food to survive, right? So don't go out unless you need to get food. And being like smart and respectful. I agree, Brandon. I think it's definitely smart to just play it safe. And if you are going to, if you do feel like if it's okay and they give you the permission, you feel like you want to see someone that's not your family, someone outside of your family, make sure that you take the precautions. Make sure you're sanitizing. Make sure you are not sick. You're making sure that everything is good. So good call. Definitely be better safe than sorry. So yeah, like I was saying, Unit 7 today, and then we're going to do the rest of the week. We're doing what's called an international practice exam. So basically what it is, it's an entire exam. So there's a multiple choice question and free response question section. My intention was if this was a normal situation, like our normal school year, that's what we would have been doing right now, is we would have been taking those practice exams. So they have, all those multiple choice questions and then the free response questions. Since this is not a normal year, we're going to just do the free response questions of it. But what's really nice is like this is an actual practice exam. So the way this is set up, all of these practice FRQs are from practice exams, or at least like they have the same setup. But this kind of puts it all into one assignment. with the calculator portion, non-calculator. That doesn't matter because your AP test, you guys will all have calculators the whole time. But still, we're going to follow that mindset. So a portion that tells you not to do calculator, I will not be using it, and neither should you. Just it's good practice, If you can do something without a calculator, that means you're in good shape. So yeah, we're gonna start on that. That should have already been assigned to you guys. That's gonna be like a really good feeling of timing for the AP exam, because the intention of that is that they put these 6 questions together, understanding you only have an X amount of time. So some are harder than others, some are quicker than others. Even though they might not be easy, they go through quicker, not less work for it, stuff like that. Just so you guys are aware, we have 6 streams left, including this one. So we have this Monday and Wednesday, next Monday and Wednesday, and the following Monday and Wednesday. Those will be the 6 streams we have left before your AP test. And then you guys will be taking that AP test not next Friday, but the following Friday. So if you guys were thinking to yourselves, like, oh, AP, I got plenty of time. It's coming up. It's creeping up on us, guys. So hopefully a lot of this practice is easing your mind a little bit and you feel pretty prepared. I saw a post from College Board saying that a lot of people are saying that this test is going to be way harder than a normal test because of the fact it's online, the situations. But AP kind of came out and said, no, that's not the case. Like that's a myth. This test is going to be the exact same type of FRQ you would get as if it were a normal AP exam. So whether or not that's true, you just got to take their word for it, I guess, right? In terms of assignments, you guys have been doing a really good job of posting your solutions to College Board. Keep doing that. I told you guys last week, and I'll reiterate that, if you want to take one big picture of all of your work, I'm okay with that now. I just want to make sure, just make it clear. I know I've messaged some of you personally if you fit this category, but not everyone's handwriting is the neatest. Trust me, I know exactly how that feels. So sometimes when you take a picture of the big page, it's very difficult for me to comprehend. Also, some people's writing is very small, and so you want to keep that in mind when you're submitting. You don't want whoever's grading your AP exam to have to like maximize and zoom in on your work. You want it to be very clear. So if you fit that category, you're taking these pictures and they just don't look good enough, I want you guys to be very precise and make them look as good as possible. So I'm also fine if you take each individual part of the question and take a picture. So like give me 1A, 1B, 1C, and 1D. Regardless of how you're doing it, everyone's doing it a little bit differently, and I'm okay with that. If you guys find yourselves having any issues submitting work, please let me know. You need to get that solved before the AP exam. So we need to find a solution if you're having issues with that. With that being said, too, the AP, you're probably going to hear this in other classes, but make sure you verify your emails. Go into College Board, go to your profile. There's a section that says where to get emails from College, where to receive emails from. That section, make sure you have an updated email because you're going to be taking all of your AP tests through an email being sent out. So they're going to send out an email with like an information on how to log in for the actual test date. So yeah, it's important you get that email, moral of the story. So make sure your email's up to date and correct and you're checking it. All right. Everything else in terms of the calendar is the same, right? We're going to do the same process. We're going to do lessons in class, reviewing homework, and then you guys will have homework. This 2017 practice exam will all be due next Monday. So you'll have the very last question will be due over the weekend, and so you should submit a picture of all of your work by Monday. Next Monday, obviously. All right. So I know that was a lot. I figured I'd get, I like to do that at the beginning of the week. Now that I have your guys' attention, you guys are all here. Or at least, the usual group is here. Figure I'd let you guys in what's going on. If you have any questions on anything, feel free to comment in the chat or email me. I'm more than happy to answer those. Okay, so like I said, we're going to start with Unit 7 FRQ Part A. So hopefully as I was talking, you guys got this assignment open. This was the question with a large vat with saltwater solution. So if you guys have any questions right now in the chat, go ahead and type them in for Unit 7 FRQ Part A. I'll go over that in the next couple minutes. I'm not going to go over the whole thing. If you have a question on every single problem, then you can ask me individually, but I will go over at least one of the parts. Andrew says part C. All right. If Andrew gets outvoted by anyone else who'd like to comment, then we can go with another one. But if everyone's okay with C, we can go C. Jasmine, I'm going to do, instead of doing B and C, I'm just going to do one of them. So I'm going to pick one of them, and then if you guys want to stop in during my office hour at some point where I can review anything else you have from it. I'll tell you what, though, I will give you the answers for everything so you know if you're doing all right. Yeah, all right, Jasmine. That was like perfect timing right when I said that. So let me actually start with that, and then I think part C might be the most beneficial to go over. Okay, so your answer for 1A should have been 60 pounds of salt. So the question said to write the equation line and use the equation for the tangent line and use that to approximate at t equals 12 minutes. You should have gotten 60 pounds of salt. Part B is it's hard for me to the question just to show that he satisfies an initial condition. So you're making two things equal to each other. Essentially, here's what you're doing. You're taking your derivative of a that they give you in the problem, and then you're taking the function that they give you, a of t. So you take a of t and you find its derivative, and you should have gotten 5e to the 0.2 minus 0.02 t. And then you evaluate the derivative of the initial condition 10 to 50. All right, and you set those equal to each other, and you should basically come to the conclusion that 5e to the 0.2 minus 0.02 t does in fact equal 5e to the 0.2 minus 0.02 t. Now, if you don't see those values, like if I'm saying those values and you don't see that, it means your answer is probably wrong. All right, and then for part C, you should have gotten your answer was your C value is 8, your K value is 2/15, and H is equal to the quantity negative 1 over 15t plus 4, all squared. Okay, so let's do 7C. I'm going to go through this pretty quickly, so try to hang along with me. Gives us the flow of the solution into a vat. The depth of the solution in the vat is modeled by function h that satisfies the differential equation. So they give us what h is. It's dh dt is equal to negative k times the square root of h. So this is the depth of the solution in the vat. T is the number of minutes since training began, k is a constant. If the depth of the solution is 16 meters at time t equals 0 and 4 meters at time t equals 30, what is h of t in terms of t? So we got to solve for h of t. So we're given a derivative and we have to solve for the original function. By now, hopefully we're okay with going from a derivative to the original, you would take an integral, right? In this case, it's a little different because we have this differential equation. So what we've learned to do, instead of taking a derivative, which we actually do take a derivative, it's just not the formal, it's not going to look formal, because we're using a certain strategy, and that's called the separation of variables. So I need to separate variables here. I need my h's on one side and my everything else on the other. So I'm going to divide by the square root of h, and then multiply by dt. So again, this is separation of variables. It's been a little bit of time since we looked at that. So I want to get h, dh, and dt on either side. So one part's getting derivative with respect to x, the other, or h, the other with respect to t. Okay, and I take the integral of both sides. That's part of separation of variables. Take the integral of both sides, and I get 2h to the 1/2, or 2 times the square root of h, is equal to negative k times t plus c. Now, the second you take the integral for every one of these problems and you're given initial values, you always want to start by subbing in those initial values to solve for c. We want to find what c is. So to do that, we're using the point 0.16. So that's a point that we're given. That's an initial condition. At t equals 0 minutes, the depth is 16. So if we use that information, we're going to get 2 times the square root of 16 is equal to c, which means 8 is equal to c. All right, and then I'm going to use the other initial condition to get k. So at 30, 4, I know that 2 times the square root of 4 should be equal to negative k times t, which is 30, plus our new c, which is 8, we found. Which means 4 equals negative 30k plus 8. I think you guys can figure out the math from there. Subtract 8, divide by negative 30, and you get positive 2/15 equals k. So it's important, right, for this first part we used 0.16 because that got rid of the k. That was important to us. So we could find c very easily without k. We're using 30 and 4 because it's not going to get rid of k. And that's what we want to ultimately find, right? That's a constant. C and k are both constants we have to get in order to express h of t and only in terms of t. So that's what the original question was asking. What is h of t in terms of t? In order to do that, we actually have to find h of t as an expression that doesn't have a k, doesn't have a c, it just has terms t. All right, now we're basically almost done here. So I get 2 times the square root of h equals, instead of negative k, it's negative 2/15. T, instead of c, it's plus 8. Divide by 2, and I get negative 1/15t plus 4. And then square everything, and I get h equals negative 1/15t plus 4 squared. And that's ultimately your final answer for C. All right, any questions on that, guys? Go ahead and give me like a thumbs up or something if you guys don't have any questions. All right, Payne said she's good. Brand's good. Alexis is good. All right. Cool. So yeah, take a look at that if that's, I know that's separation of variables is important and something that we haven't seen in a little bit of time. That was like, I mean, that was the last thing in school we kind of covered, but not the easiest thing to remember. So there was a lot of things I took for granted in that explanation. Make sure you go back through. If you have little questions on my process, make sure you come and ask me, email me, or stop by in office hour. All right, so let's open up then 7 FRQB. So go ahead in the chat, Let me know when you're ready to start on that. So you got it open, ready to go. Your notes are out. And then take a look at the question too. So take like a minute or two and process what the question or what information is given to you and what the question is. Thank you guys. Thank you. All right, so at least 3 of the 10 are ready. Andrew says he's ready. Perfect. Thank you, Andrew. All right, so it looks like at least half of you are ready. I'm going to take that as if not, you're about to be. Not too much going on in this question, the first part. So this is 1. And I'm putting 1b specifically because I'm not going to write down 1a. So it just says consider differential equation. So unit 7 was differential equations. So this is unit 7 FRQ. So we can expect to see them. Right, so it just says consider the differential equation x times y cubed. Okay, I'm going to go over my screen here. So I don't have to write down these dots. And the first question said, on the axis provided, sketch a slope field for a given differential equation. All right. So here's the deal with this, guys. Obviously, this is very difficult for them to replicate. So if this was like an AP test, you would actually write down that graph. You'd put down every single one of those dots, and then you'd give a little sketch of what direction they're going. Now, what I don't really want to do that just because it's going to take too much time. So on your paper, what I would do is just do like right now as I'm talking, do a quick sketch, try to listen to what I'm saying, and then I'll show you what we should be doing. So we're sketching a slope field. Slope is just going to be a way to determine the slope at every single point. Well, a slope at a point is called a tangent line. It's called the slope of a tangent line. Slope of a tangent line is found using a derivative, right? And guess what? We're given a differential equation. I mean, we're given a derivative equation. dy dx equals xy cubed. So if we want to find the slope at every point, we just got to find values of x and y and plug them in. So for example, 0.00. If I plugged in 0 for x and y, you're going to get the derivatives equal to 0. So you'll see on the answer, which I'll scroll down and show you guys, the answer at 0, 0 is a horizontal line because the slope is 0. And that's true for every single value on an axis. Because if x is 0, y is 0, that means that that multiplication will always turn to 0. So the slope at each one of these points is 0. The slope at negative 1, 1, when x is negative 1, you would plug in negative 1 times y to the third times 1 to the third, gives me a negative value. So you guys can see this slope is negative. Down 1 to the right 1. That would be a negative slope. Same thing with 1, negative 1. There's a negative slope. At negative 1, you're going to get a positive slope because you're going to have a negative times a negative, which gives you a positive number. So you'll see they have a positive slope here at those values. And that sums up the slope field, how you go about doing that. You're just plugging in values into your differential equation. Whatever your answer is tells you how steep of a line you want to draw at those points. Don't have to be exact, just have to have like a general idea of what's going on. All right, so go ahead and chat type if you have any questions on that. I'm going to move on if not. And we're going to look at 1b. So 1b says to find the second derivative in terms of x and y, and then to determine the concavity of your solution curves in quadrant 4. Okay, well, before I do any of that determining concavity stuff, I just want to first find the second derivative. In other words, I want to find what's d2y dx squared. What is that second derivative? Well, to find the second derivative, I'm taking the derivative of the derivative. So if my original function, I'm just going to write it up here, was dy dx equals xy cubed, to find that derivative, I'd use product rule. So product rule says first value times the derivative of the second value. Remember, this is in terms of x. So taking the derivative of y cubed with respect to x is 3y squared times the derivative of y. It's called implicit differentiation, right? So we've seen that a ton. Just you got to always remind yourself what is this derivative being taken with respect to. Okay, and the product rule says plus the derivative of x, which is 1, times y cubed. Now, you guys notice in the question it says to find the second derivative in terms of x and y. So it specifies in terms of x and y. Well, I did that, except I also found it in terms of y prime. So in order to find it in just terms of x and y, I got to get rid of y prime somehow. And to do that, I just plug in what y prime is. Y prime is xy cubed. So I'm left with x times 3y squared times xy cubed plus y cubed. If I were to simplify this down, I get 3x squared, y to the fifth, plus y to the third. I'm going to box that in. That's the first part of the question. So we just found the second derivative right there. Now the second part of the question says to determine the concavity in quadrant 4. So if we're determining concavity in quadrant 4, we have to determine what is happening with the second derivative. Second derivative tells us concavity, meaning if the second derivative is positive, that means we know it's concave up. If the second derivative is negative, we know it's concave down. So in quadrant 4, let's take a look. What is some stuff we know? Well, in quadrant 4, we know that the x values are positive. So x is greater than 0. We know that all the time. That's where the quadrant 4 on the coordinate plane is when x is positive, and when y is negative. So we know in quadrant 4 x is greater than 0 and y is less than 0. Now let's break apart the second derivative. So basically, what do we know is true about 3x squared times y to the fifth in quadrant 4? Well, if x is greater than 0, that means it's going to be 3 times a positive number, because a positive number squared is positive still. And if y is always less than 0, it'd be positive times negative, no matter what in quadrant 4. Which means that 3x squared times y to the fifth is always less than 0. So that's for all values in quadrant 4. Okay, now y cubed. What do we know is true about y cubed? Well, we know that y is always negative. So a negative number cubed is always also going to be negative. So y cubed is less than 0 for all values in IV, or in quadrant 4. So this is what we just found out. We found out that the first part of the second derivative is always negative. The second part of the second derivative is always negative. A negative plus a negative will still be negative. So moral of the story, what we have ultimately wanted to find out, should be an x, is less than 0 for all values in IV. So your actual concavity is concave down. All right, so there's a lot to that problem. First things first, you split it up. Okay, the first part of the question just says find the second derivative. So I just focused solely on that, which is that first step up here. Second question that asks about concavity. Whenever you see the word concavity, I want you guys thinking second derivative. So we already got the second derivative. That's what we found in the first part of the question. That was the point. Then we just had to determine, based on the fact it was in quadrant 4, what is the behavior of the second derivative? Well, it's always negative. The second derivative is always negative. A negative second derivative is telling us concave down. So all the solution curves for the given differential equation are all going to be concave down. And then all that in between was the reason why. Any questions you guys have, go ahead and throw them in the chat. If I don't see anything, I'm just going to keep flying through this problem. And I don't want to be flying through if you guys are all stuck. So let me know. All right, 1C says, you guys can tell this question doesn't have too many parts. There's not a lot of words involved, but there's a lot of still work involved. So C says to find the particular solution to a given differential equation with initial conditions. Okay, whenever you're asking to find a solution to a differential equation, you guys need to be thinking separation of variables. Got to be thinking that. So I'm originally given dy dx equals xy cubed. I need to perform separation of variables on that. So I'm going to divide by y cubed, so I get 1 over y cubed dy equals x dx. Separating variables, right? I put the x's on one side, the y's on the other. Okay, now I need to integrate both sides. You'd want to change this to y to the negative third and integrate that normally, and you would get negative 1 over y squared, 1 over 2y squared is equal to 1/2 x squared plus c. And after the first time after you integrate, you always then want to evaluate for c. So using the initial condition to -1, we're going to plug those values in to solve for c. So I'm going to get -1 over, in this case it's going to be 2 is equal to 2 plus c. So -5/2 equals c. Payne said, wouldn't it be 3? What part, Payne? Maybe specify? Oh, okay. All right, cool. All right, so we got c. So now we're left with -1 over 2y squared is equal to 1/2 x squared minus 5/2 now. So to find a particular solution, that's a y. We got to solve for y. All right, and there's a lot of steps to this. A lot of different ways you can go do it. I'm going to just multiply each side by 2y squared. Divide both sides by the inside of the parentheses. Divide by 2. So I get negative 1 divided by x squared minus 5. I'm going to factor out a negative 1. Hopefully you guys can see this. Am I too low? Oh, you can see it. All right, so I'm going to factor out a negative 1. So I'm going to be negative 1 times 1 over 5 minus x squared equals y squared. And now this part becomes a little bit trickier. Actual answer for y. So my final answer ends up being negative square root of 1 divided by 5 minus x squared equals y. So the tricky part is you guys might be asking yourselves, okay, Mr. Harris, I'm following everything. You took the square root. How come it's just negative? And the reason being is because of this in the blue right here. If it were positive, if the answer was positive, you would never get the answer of y equals negative 1. That would never be able to get that solution. Because a square root's always positive, which means that a positive times a positive would be a positive number. You couldn't get negative 1. So simply because our initial condition was given that the y value was negative, we know our answer, our particular solution, should have a negative out in front of the square root. Okay, that's probably the hardest part about this question, because that's the one part that's not like a cookie cutter formula or strategy to solve. It's just kind of thinking about, okay, if my solution has a negative, I know it has to be a negative out in front of the square root. All right, that was Unit 7 FRQ B. Before I move on, part 1. We still got part 2, but for part 1. Before I move on, do you guys have any questions? Okay, I'll take that as a no. So let's look at part B then. So go ahead and turn the page over, I guess. And I'm going to flip over my screen again so I don't have to draw this out. So this is a question I'm pretty confident you won't see on an AP exam, for like in our situation, our AP exam, just because of how it's set up. It makes things a little complicated to draw on a piece of paper. So I doubt they would give you something like this, but it's good to look at. So again, not giving much information. We're just given a differential equation. Okay, so we're given this differential equation. In this case, it's y minus 1 times x plus 1 cosine x squared plus 2x plus pi. And it says a portion of the slope field of the differential equation is given below. Sketch the solution curves. So this is my slope field. To find solution curves, guys, all we're doing is following these lines. So my first solution curve is between the point 0, 1. So you see this point 0, 1? I'm going to follow the lines up to that point. And guess what? It's just a horizontal line. That's all it is. Just the horizontal line. So in your answer, you would just draw a horizontal line at 1. At 0, 5 halves, it's a little bit different. You guys can see your graph would look something like, here's the point. You would follow it this way. So it goes up, and then levels off, and then goes back down. And then on the other side, it goes down, and then up, and then back down again. So again, you're just following the curve of the slope field. And so your answer would look something like this. So again, horizontal line, and then for 0, 5 halves, it goes up, and then down, and then up, and then down. And you can see how like that line almost perfectly follows these arrows. All right, so that was part A. Just drawing a picture, which is nice. Part B. Let's take a look at that. 2B. Question says, write an equation for the line tangent to the solution curve in part A at the point 0, 5 halves. So we're writing an equation to a tangent line. All right, well, in order to write an equation of a tangent line, we first need to find a slope of tangent line, which can be found by finding dy dx at the point 0, 5 halves. So whenever we're finding a slope of a tangent line at a point, we plug that point into the derivative. Well, guess what? This question gave us the derivative to start the question. We say the derivative is equal to y minus 1 times x plus 1, blah, blah, blah. So all we got to do is we plug in 0, 5 halves into that equation that they gave us, and we get our slope at that point, which is equal to negative 3 halves. To get an equation of a tangent line, all you got to do is use point-slope form. So it's y minus y1, which is 5 halves, is equal to the slope, negative 3 halves, times x minus x1, which is 0. Okay, solving this, you add 5 halves to both sides. This turns into just x, so minus 3 halves x. And bam. That's all it is for 2b. I really hope you guys are picking up that slope of tangent line is all over the place. Like, I would be very, very, very surprised if on your AP test you guys don't get a question that says something about a slope of a tangent line. Whether it involves differential equations, integrals, derivatives, I don't know. But they have to incorporate this somehow. So you have to understand, to simplify slopes of tangent line problems, you're always going to find a derivative. You always need a derivative or a rate of change. Always. You always need to find the slope first and then use point-slope form to get an equation. If you have a problem with point-slope form at this point, we got some work to do. Got to go back and review that. Hopefully we're all okay with that. Finding the actual points of x and y are easy. That'll always be given to you. Or at least one of them will be given to you, and you can find the other based off of that. So if you're just given x, you can find y by plugging into a formula. Regardless, you'll have enough information to find them. And then the slope is usually what you have to solve for. And you can solve for that in so many different ways, which is why AP loves using this question. All right, now 2C, guys. This question is fun, so this will take probably the rest of the class, so buckle in. All right, and the question says to find the particular solution to a differential equation with initial condition. This is the same question we had for part at 1. Same exact question, so we're going to use the same exact process. All right, now the only difference is that this formula, this equation isn't so pretty. So I'm given dy dx is equal to y minus 1 times x plus 1 times cosine of x squared plus 2x plus pi. That's what's given to me. I need to, in order to solve this particular solution, I need to definitely use separation of variables. That's always the case. So I'm going to put all the y's on one side. You'll notice that the only part that has y's is this y minus 1. So I'm going to do 1 over y minus 1 dy is equal to x plus 1 times cosine of x squared plus 2x plus pi. I'm putting way too many parentheses. Oh well, dx. Now this is where it gets interesting, when we actually have to take the integral of both sides. Okay, the left side is not too bad. Left side is just natural log of y minus 1. Those are absolute values, by the way. Natural log of y minus 1. Now, how do I find the integral of this? So you guys are looking at that. I'm thinking you're looking at it and you'd be like, oh, Mr. Harris, no way. I can't do that in my head. And you would be correct. Okay, you're not going to be able to look at that and just know right off the bat, like, this is the integral. Which is why we have this very useful tool to solving integrals whenever we're stuck, and it's called U substitution. You can notice, right, I have a function, x plus 1, times another function that's composite, cosine of x squared plus 2x plus pi. So it's a function times a composite function. And the original first function, if you take the derivative of the inside of the composite function, you can get to there. So that's the big key. This is like a perfect prime setup for U substitution. So we want to let U equal the inside of the composite function, x squared plus 2x plus pi, which means du is equal to 2x plus 2 dx. If I factor out a 2, I get 2 times x plus 1 dx. Why did I do that? Because I'm ultimately looking to replace x plus 1 dx. Notice now I have an x plus 1 dx. So to get that by itself, I divide each side by 2, and I'm in business. So what I'm really integrating is, instead of x plus 1 dx, I have 1/2 du. And instead of cosine x squared plus 2x plus pi, I have cosine of u. So I'm left with 1/2 cosine u du. U substitutions, everyone's favorite. Now that was already a lot of work, but I have a long way to go still. So now I actually have to go through and integrate that. So the integral of 1/2 cosine u is going to be, in this case, 1/2 sine of u. And of course, plus c. Okay, I'm going to keep plowing through. I cannot write this in terms of u and y's and x's and all the, we want to get in terms of x and y. That's what our solution needs to be in terms of. So instead of sine of u, I'm going to replace back u. So x squared plus 2x plus pi, and then plus c. So this is where I'm at now. Like I've been saying, right after you take the integral, once those signs are gone, you added your plus c. Now you want to definitely evaluate for c. So now's the best time to do it. So we want to find c at the initial condition 0, 5/2. Which means I get the natural log of 5/2 minus 1. Sorry, these absolute values keep turning badly. Is equal to 1/2. Sine of 0 plus pi is 1/2 sine of pi plus c. Sorry about that s. Well, sine of pi is going to be 0. So I'm left with just natural log of 5/2 minus 1, which is the natural log of 3/2, is equal to c. But I'm not done. The question asked me, what did the actual question say? The question said to find the particular solution to the differential equation. So I'm finding a particular solution. It needs to be y equals something. So I'm going to replace c with natural log of 3/2. So I get natural log of y minus 1 equals 1/2 sine of x squared. I had to fit that in there. I ran out of room. And I just need to isolate y and I'm done. Okay, so in order to get rid of the natural log, I take e to both sides. So e to both sides, I get y minus 1 is equal to e to the 1/2 sine of x squared plus 2x plus pi plus the natural log of 3/2. So if anyone is really having a hard time reading that or understanding, I just took the entire right side and put it in the exponent of e. So I changed the base to both sides to make it base e. And e to the natural log of y minus 1 is y minus 1. Okay, then you just got to add 1 and simplify. So y is going to be equal to e to the natural log of 3/2. So remember, when you're adding things in the exponents, exponential laws tell us that we can separate it by multiplying them. So e to the 1/2 of that times e to the natural log of 3/2. Well, e to the natural log of 3/2 is equal to 3/2. We don't know what e to the 1/2 sine of x squared plus 2x plus pi is, so we just leave it as e to the 1/2 sine of that. And then we added 1 to both sides, so that's going to be plus 1. Right, because it was y minus 1 equals that, we add 1 to both sides, and you get y to the other side, or 1 to the other side. All right, I know there was a lot to that problem. That was one of the longest problems we've done in calculus, really. So I got about 3 minutes left. That's the last thing, part of this assignment. So if you guys have any questions at any step in that, ask it now. Go ahead and ask. If you don't have any questions, then you are good to go. Hope you have a fantastic day. This assignment for homework is due next Monday, like I said. So don't stress about it, but try your best to get it done. You don't want to procrastinate on this FRQ, by the way, guys. So this 2017 FRQ, you want to make sure, do the homework as it's given to you, or you're going to fall behind. It's going to be too much to catch up on. That wasn't very cash money if they paid to do us like that, for real. Yeah, I know, Brandon. It's a fun problem, though. It's a lot of work, but it's gratifying work once you get to the answer. Just remember, Brandon, there was classes before you that probably had a question exactly like this on their AP test, and had to do this all with no notes, no calculator, nothing, just winging it. Remember, guys, I have my office hours, so I'll be back on from 1 to 2 today. So if you guys want to stop by and ask questions on anything, if you want to start your homework until then, and then you can ask some questions on whatever you got to do. I'm glad I'm not them. All right, calculus. Have a great rest of your day, people. If you guys are in Algebra 2 and you're in the chat right now, go ahead and comment. Let me know you're here. There you go. Sarah's here. Yes, I did, Sarah. I'm sorry. My Wi-Fi gets really bad. Like it's hard to like check things. So I'm guessing, Sarah, maybe I just missed your submission um, for Google Classroom. So I'll just when I'm done with the stream and like I get my, I'm not lagging. I'll go in and check Sarah for the email and everything, and check your work. So I'll email you back, Sarah, if I need you to send your work over email. I might have just missed it in Google Classroom. Hello, Tanis. Hello, Chris. Good to see you guys. So while we're getting ourselves together, how was your guys' weekend? You guys do anything fun? Anything new? Exciting? You played video games all weekend? Did you go for a run? Did you like? Well, I want to hear how everyone's doing. Did you like Mr. Harris's stream already? Are you working on that? Those are like the big questions in life. That's kind of what I want answered. Let me show you my face. What's up, Algebra 2? Make it a little more personable, you know? If anyone's curious, my weekend was alright. I got to see my parents and my brother, which was good. So I went to my parents' house, and my mom made like homemade Chipotle bowls. Oh, it was fantastic. I wish I would have leftovers, but we ate it all. But yeah, we had I think it was like homemade Chipotle bowls. So you could do like sour cream, cheese, meat, rice, beans, queso. Oh, so good. One of my favorite things that she makes. And so yeah, I really enjoyed that. That was awesome. And we did like a puzzle, but it wasn't like a typical puzzle. It wasn't like here's a picture, like try to make a puzzle out of it. Like it was a puzzle with only like 12 pieces, but it was you didn't have like a picture to go off of. You just had to kind of figure it out. And every piece like fit the same. They're little triangle pieces. It's kind of hard to explain, but it's a puzzle within a puzzle. And I was basically my brother and I were just like thought it was gonna be the easiest thing ever, and it turned out to not be the easiest thing ever. We were trying to like reason our way through, and then eventually I got mad, and I was like, I'm just gonna start putting pieces that look close together, and I just started throwing them together, and next thing I knew, the puzzles kind of came together, and I got it right. But I thought it was really funny. Like reasoning didn't help at all. It's just like you pretty much just had to get lucky. So we just started winging it. Yeah, so that was fun. I did a Zoom with some friends, which is always good. I recommend that if you guys are ever bored, and you miss your friends, do a Zoom. A house party I heard is pretty good too, because I think they got like games you can play on that one. Just something fun to do while we're all in quarantine. No one answered how their weekends were, so I'm assuming you guys are just all typing and you're having these long messages about all the stuff you'd like to talk about, or more likely you're probably just ignoring me. That's okay. If you guys are being shy like the first day of school, you don't wanna like talk about stuff. That's fine. Give it about a minute more, see if anyone else pops in to the chat. And then we will get started for today. If you guys haven't, go ahead and get the calendar open. Take a quick peek at that. I'm going to start there. So let me change my camera over so you can see my screen. There we go. Okay, so let's go ahead and get started. Welcome, happy Monday. Today is what, April 27th. So I think Yeah, Friday is the beginning of May. Crazy, guys. We get out June. I don't know what day in June. I can't remember. But we got a little over a month left of school. So your junior, sophomore, some of you even freshman years are almost done. As you know, obviously, unfortunately, we'll be doing it from home. So everything for the rest of the year will be done from home, which is too bad, but we're gonna make it work. June 7th. So yeah, I asked for everyone's weekend is. No one seems to answer, and I say what day do we get back? And Digidio right away says, oh, we're done with school the 7th. I'm just messing around. Cool thing though about this week is Governor DeWine is supposed to make some announcements. As you guys probably know, Friday is supposed to be the day like things go a little bit back to normal. So I think it's kind of broken up into phases. And thank you, Sarah. Good to hear you had a good weekend. Happy to hear. Yeah, so it's like broken up into phases, right? And I think the first phase is supposed to be implemented this weekend. I think this weekend. I think May 1st is supposed to be like that first day. So, guys, keep an eye out for that. I'm sure you'll be getting information, but maybe things will change a little bit. I think we're going to make a little bit of a push to get back to normal. I don't know what that means. It might just mean that more businesses will open back up. And the precautions will still be there. You'll still be people will still be wearing masks. 6 foot apart from everyone. Like I think all that's not going to change. You might be able to gather in like smaller groups more frequently. They might say like as long as you're maintaining 6 foot from each other and all that good stuff. Just keep an eye out. I don't know what kind of changes are going to be made, but it's exciting at least that maybe we're going to make some progress this week towards normalcy, getting back to how things were. Just because that's the case, though, don't take it don't be crazy about it. Don't go nuts and have like your entire class together and be like, hey guys, let's all hang out together. And that's not smart. You still want to be smart. Understand it's still out there. Nothing has changed. I think they just want to. The economy really just needs people to get back to work. So it's inevitable that things somewhat have to return back to normal. But make sure you guys are smart and responsible about stuff. So today we're going to be doing 8.2 notes. If you guys remember, a little recap of what we've been doing the last 2 weeks is we've been working with rational numbers. If you guys remember correctly, I'll flip over to this page here. I don't know if they have any sort of, I don't really talk about it, but polynomials, so they see these kind of multiple polynomials, that's the key, right? A rational number is, what is the word I'm looking for? It's a fraction where the numerator and denominator are both polynomials. So we have any sort of fraction with polynomials in it, we know it's going to be a rational expression. As we know by now, with polynomials, you have variables that are raised to certain powers. Big stipulations is you can't have negative exponents and you can't have fractions in your exponents, or that wouldn't be a polynomial. So everything else classifies a linear as a polynomial, a constant, quadratic, cubic, all those, quartic. Those are all examples of polynomial functions. So if you have a numerator and denominator, they're both a polynomial function, you have a rational function, or a rational expression. All right, so 8.2 is going to talk about that. We don't have too much today in terms of notes. It's going to be stuff I don't think you guys are going to have a huge issue with. Probably even easier than what we were doing with multiplying. So multiplying and dividing was all of last week. Rational expressions. Today we're going to do adding and subtracting rational expressions, which I would say is probably easier. So I think today will be a pretty light day. You have Khan Academy for homework. So there's 3 different assignments. They're due Friday. There are 4 questions each. So Khan Academy has 4 questions each. The questions will repeat themselves. So if you do all the work, don't feel like it's going to be a waste of time if you get it wrong. Because if you do all the work for it and have your work and you get the answer wrong, you'll have something to work off of. So like the second time through, if you want to get 100%, you want to do it a second time or third time or fourth, it should continually get easier and quicker because you're already going to have the answers to the other questions that you got right. So just keep that in mind. Like when you're working through these, make sure you you write them in your notes. So you have the work, and the ones that you do get right, you don't have to do the work over again. You just have the answer, you just plug it in when you do redo. So just remember that with Khan Academy. There's 3 assignments, due Friday. Questions you have throughout the week, ask me. On Wednesday, I don't know why my calendar forgot to put this, but we're doing 8.4 notes during the lecture. So we'll be doing unit 8.4, which is graphing rational functions. This unit's kind of weird. It went like backwards. Before we were like, most units we start with graphing, and then we go into adding and subtracting, and then we go into multiplying, dividing, and simplifying. This one's opposite. We start with multiplying, dividing, simplifying, to adding, to subtracting, and then to graphing. I don't know why, but I'm just kind of following that line of the book. So yeah, we'll do that, and then you'll have an Alex assignment that'll be due Friday as well. So that'll be an Alex assignment for 8.4. A lot of just graphing functions. You can use Desmos, but the main thing with 8.4 is we'll talk about is key features of a rational function graph, which were known as asymptotes. So you guys have seen that before. We've talked about that a little bit. Asymptotes basically are lines, like made up lines that numbers or graphs can never hit. All right, meaning the graph will never touch that line. That's what we call an asymptote. And 8.4, we'll obviously when we get there, we'll get there. Friday will just be a review day as usual for Alex and Con. So any questions you guys have throughout the week on those two assignments, Friday will be an hour where you guys can stop in and we can go over that. All right, so that lays out the week to come. So what I would like to do next, and what I want you guys to do, is we need to turn to page 538 in your book. Jaden, good to see you. $538. Don't need to ask me what page number, because guess what? It's in the chat. Go ahead and give me like a thumbs up or like I'm here or something when you guys get to page 538 so I know I can get started. Thank you, Tanis. Thank you, Jaden. Thank you, Haley. How many people are in here, by the way? Should I check that? 8 viewers? Ho ho. Nice. It's actually, I think, more than usual. Watch, I say that, and now 7 people are going to leave. Left with that, just myself. All right, so at least 3 of the 8 are there. I'm assuming the rest of you guys are about to be there, or if not, you are there and you're just not talking, which is fine. So let's get started on this. Let me zoom in just a little bit. Adding and subtracting rational expressions. So here's a little why I like to read these. I think these are just interesting. So it says, as a fire engine moves towards a person, the pitch of the siren sounds higher to that person than it would if the fire engine were at rest. This is because the sound waves are compressed closer together, referred to as the Doppler effect. Hey, Aiden, good to see you. No worries. Aiden, we're on page 538 in our notes, so you can go ahead and get that open, and you'll catch right back up. So this is called the Doppler effect. It can be represented by a rational function. So that's just an interesting part of life that we can actually calculate using a rational expression, which is pretty interesting. So you need the actual pitch of the siren, you need the speed of the fire truck, and you need the speed of the sound in the air. So you need some details in order to calculate it, but you can get that Doppler effect. I mean, we've all seen this and like listened to this and understand what this means. It's kind of that idea of going like that kind of sound of a car flying by. That's usually what we do. In this case, they do this pitch of a engine, or the siren, I mean. So, we've heard that before, but it's kind of cool that we can apply a rational expression to that to actually solve for the actual sound. All right, so you guys see, we've already talked about rational expressions, so we should have a pretty good understanding of that. We've done multiplying and dividing rational expressions. Today we're going to do adding and subtracting. The first part here I'm not going to worry about. It's about least common multiples. I'm just going to read this real quick, and we're not going to do any work with it, but just so you understand and a reminder of what least common multiples is. So just as with rational numbers in fractional form, to add or subtract two rational expressions that have unlike denominators, you must first find the least common denominator. So the least common denominator is the least common multiple of the denominators. All right, and that's the key. So generally, the general rule of thumb we're going to use, well, I mean, that is the rule of thumb we're going to use, least common multiple. You can actually, when we're doing these, is you can not use least common multiple. You can just multiply the two denominators together and then simplify after the fact. But we want to get used to using least common multiple. I don't want to go over this because I think this is something that we're used to. Or something that we've seen enough of. So let me, 8.2. So if you guys have it in your notes already, put the title of this. So 8.2, adding and subtracting rational expressions. So let me go to my camera here. Of course, I do this every single time I write a title. I started off way too big, and I realized I wasn't going to fit it. So you don't have to write it like this, however you want to title it, but this is what 8.2 is talking about. And last week when we talked about multiplying and dividing, I started off by said, okay, here's just a fraction. How do you multiply and divide fractions? Well, you multiply numerator times numerator, denominator times denominator. And if you're dividing by a fraction, you have to multiply by a reciprocal. So you're never really dividing fractions. You're always just multiplying them. Okay, adding and subtracting a fraction, like not similar, but it's, it has one way we do that. So if we have something like 1/4 plus 2/5. Okay, you don't need to write this down, but let's look at that. So I said we hate fractions. I shouldn't say we, I love fractions. But I know as a class, you guys don't love fractions. And so when you're given something like this might make you uncomfortable. Okay, whenever we're given fractions and we need to add them without a calculator, well, we have to make like denominators. So we have to find a common denominator. And that's what we call the least common multiple between 4 and 5. So the least common multiple between 4 and 5 is those two multiplied together, which is 20. So I would have something over 20 plus something over 20. All right, to get to 20, I would multiply this whole fraction by 5. So 4 times 5 is 20. 1 times 5 is 5. So 1/4 is equal to 5 over 20. 5 times 4 gives me 20, so 2 times 4 gives me 8. So 2/5 is equal to 8 over 20. Now the difference between multiplying, dividing, and adding, right, is when you add them together or subtract them together, you keep the common denominator. So 5 over 20 plus 8 over 20 is the same thing as 5 plus 8 over 20, which we know is equal to 13 over 20. All right, so that's how I add and subtract just normal fractions. And you guys have been doing that for quite a bit of time, at least since Algebra 1. But I'm sure before that, I don't remember exactly what class you take when you're little, but this idea of adding fractions is you guys have seen for a long time now. Now, what we're doing is we're taking this and applying it to algebra, though. Specific algebra 2, obviously, and we're going to apply it to what we're working on now, which is rational expressions. So on page 539, you guys can see at the top of the page, we're going to get started on how we can do that. So you have a big 2, it says add and subtract rational expressions. As with fractions, rational expressions must have common denominators in order to be added or subtracted. So it's the same idea, guys. The only difference is instead of just numbers, we're going to have variables. It's going to be some sort of polynomial over polynomial plus polynomial over polynomial. Find a common denominator, and then you add them. Adding and subtracting is the same thing, guys. You're doing the same process. The only difference is one of them you're subtracting, one of them you're adding. So like if this was 1/4 minus 2/5, I would have just done 5 minus 8. Okay, I don't think that's crazy new revelation to you guys, right? But I'm not going to treat these as two separate problems. Adding and subtracting rational expressions is all just one type of problem. It doesn't matter if it's adding or subtracting, you're doing the same thing. Okay, and there's a couple ways we can do this. So there's different examples. One of them is a monomial, and then one of them is polynomials. So a monomial is just one singular term. It could have a bunch of different variables, but it's one term. So a monomial rational expression is when it has a monomial over a monomial. So we're going to start with that. That's the easier version, and then we'll get into the polynomials. So if you guys look at example 2, we're just going to dive right in, and we're going to solve that one. So 3y divided by 2x, oh boy, cubed plus 5z over 8xy squared. That's 5z. Again, not s to z, it's 5. I just don't draw good 5s. It's problem 2 in your book. So the question just wants us to simplify. Notice that's all we've been doing, guys, for this unit, is we've been simplifying. All right, and so the first step we need to do is find the least common multiple of 2x cubed and 8xy squared. So I'm going to do this two different ways. Let me see. I haven't checked this out, so I'm not. Actually, no, I'm not going to. I don't want to confuse anyone. So I'll just stick to the idea of a least common multiple. All right, when I'm finding the least common multiple, so I'm going to write this on the side here. So the least common multiple of the denominator. I have to start with each individual piece. That's how I want to approach it. So least common multiple of 2 and 8. Let's start there. Least common multiple of 2 and 8 is going to be 4. Or sorry, let me rephrase that. Least common multiple of 2 and 8 is going to be 8. We would have to multiply 2 times 4 to get 8, but that's going to be least common multiple, because 8 times 1 is 8, 2 times 4 is 8. Least common multiple of x cubed and x is going to be x cubed, because x cubed times 1 gives me x cubed, and x times x squared gives me x cubed. So they both can be multiplied into x cubed. All right, and the last one is just y squared and nothing. So least common multiple, or I should say y squared and 1 in this case. But moral of the story is we want to multiply by y squared. So their least common multiple has to be y squared. So the total least common multiple is going to be 8x cubed y squared. Which means I need to write both of these fractions. I need to rewrite them so that I have a denominator of 8x cubed times y squared. And now whatever we did to the denominator, we have to do to the numerator. So if I needed to get to 8x cubed y squared, what did I have to multiply 2x cubed by to do that? Well, the first thing I needed to multiply by was 4, because 2 times 4 is 8. So 3y, or 3 times 4, is 12. So I have 12 in the numerator. I didn't have to multiply by x, because 2x cubed and x cubed, they're both x cubes. So I don't have to worry about the x's. And then how do I get to y squared? 2x cubed times what gives me y squared? That's y squared. Now, one thing I want to make sure we're not forgetting is in the original question, it was a 3y. So in that case, to get to, all right, so we had to multiply by 4y squared. Okay, so 3y times 4y squared is 12y cubed, actually. So we determined that in order to get from 2x cubed to 8x cubed y squared, we have to multiply by 4y squareds. So 3y times 4 is 12. 3y times 4y squared is 12y cubed. Okay, same thing here. So in order to get to 8xy squared, I have to multiply the denominator by 8 stays the same, those are good. Y squared stay the same, those are good. So I have to multiply by x squared. To get from x to x cubed, I have to multiply by x squared. So I multiply the numerator by x squared, and I get 5x squared z. Last step is we put these together into one fraction. So if you have like denominators, you can always combine them into one fraction. So I get 12y cubed plus 5x squared z. So do you guys have any questions on that problem? So go ahead in the chat. Type in any questions you have. Don't be shy. How do we feel about that? Monomials. Alright, so Chris says, where did 5x squared come from? Alright, so Chris, this 5x squared came from the fact that in order to get to 8xy squared into 8x cubed y squared, I'd have to multiply by x squared. So whatever I do the denominator, I have to do the numerator. So if I multiply the denominator by x squared, I have to multiply 5z by x squared. And that gives me 5x squared z. So that's where the 5x squared came from. Okay, and if you guys think you're good, I want you to try one for yourselves. So I want you to try 2a. So guided practice 2 capital A. I will write it up here so you guys have it. Alright, so that's the question. Go ahead and get started. Looks like Aiden got an answer. Tannis is good. It's okay, Aiden. No worries. Chris is done. Thank you. All right. Looks like people are finishing up. Maybe a minute or two more. All right. So let's take a look at this. So if you're not quite finished up, that's okay. Go ahead and check your work. Okay. So first things first is we want to find a least common multiple of the denominator. So between 5 and 10, their least common multiple is 10. 5 times 2 is 10. 10 times 1 is 10. Between a cubed and a, their least common multiple is a cubed. A cubed times 1 is a cubed. A times a squared is a cubed. B squared and b, their least common multiple is b squared. B squared times 1 is b squared. B times b is b squared. So this is your overall denominator. So I need to make two different fractions, one that has both with the same denominator. 10a cubed b squared. So make sure just right off the bat you guys are okay with that part. So you got that answer, or at least the denominator correct. That's a good start. Now we just got to get the numerators. So let me back up. 5 times what gives me 10? A cubed times what gives me a cubed, and b squared times what gives me b squared. Well, 5 times 2 gives me 10. A cubed stays, b squared stays. So you just have to multiply the denominator by 2 to get to 10a cubed b squared, which means I multiply the numerator by 2. So I just have 8. Okay, same thing here. So 10 times 1 is 10, so that's good. A squared times a will give me a cubed. So I have to multiply 9 times a squared. B times b gives me b squared. So 9a squared b. And then last thing is then c. C just stays the same. So there's no c in the denominator, so we just keep the c up in that numerator. One thing you guys, maybe it might help you guys if you want, is you can make like a little arrow to show like, okay, how do I get from here to here? Well, I multiply by a squared b. So then you just take the numerator and say 9c, multiply those together, and that gives you whatever the numerator is. So 9c times a squared b is 9a squared bc. Okay, so however you guys are doing that process, I'm not, whatever works for you works for you. So as long as you understand how I'm getting these numbers. And then last thing, easiest part, combine it into one fraction. So 8 plus 9a squared bc over 10a cubed plus b squared. So go ahead, guys, in the chat. I'd like to see who got this right. And if you have any questions if you didn't. So who got this 100% right? I would love to be able to go around and check your work, but I can't do that. So I just gotta pick your brains. How did we do? Good job, Sarah. That's what I'm talking about. Egidio got it right. Who else got this right? Let me see what. Looks like Aiden's answer was a little bit off. Tanis, Haley, good job, guys. Awesome. All right. I think Aiden just accidentally put. Yeah, I think Aiden, you forgot to multiply the numerators together. If your answer in the chat, but. All right. So I'm guessing the rest of you are just being shy. The other 6 people are being shy, or maybe you got it wrong. You just don't want to say. I don't. No big deal, regardless of why. But just think to yourself, if you did get it wrong, I would love to hear some questions because there's no way for me to check your work to see what happened. So we're gonna get a couple more practice though. So don't panic. I'm gonna flip the page now. We're gonna do example 3. So we're gonna do this one together, and then same idea. I'll give you guys a guided practice you guys can do. So we're sticking with the same idea, adding and subtracting, except now what we are going to be doing is we're going to be working with polynomial denominators. So we want to simplify this expression. 5 divided by 6x minus 18 minus x minus 1 divided by 4x squared minus 14x plus 6. Okay. So I want to make this very clear. And I made this clear also with multiplying and dividing polynomials, or rational expressions, is you always want to factor first, guys. That's what you want to do first. Don't wait to factor. Don't try to get a common multiple right off the bat. Factor first before you do anything. The reason being is because we can get the denominator of just terms being multiplied. It's going to be much easier for us to find the least common multiple. So factoring is going to help us. So we got to start there. All right, if you notice, the numerators of both are going to stay the same. Those aren't going to be factorable. But the denominators can. So the first denominator is 6x minus 18. You can't factor it because it's not quadratic. So we're not going to do like an X box and all that. But I can factor out a greatest common factor. 6 and 18 both have 6 in common. So I can rewrite this as 5 divided by 6 times x minus 3. Okay, let's look at this denominator. It's a little bit longer, more complicated, which is kind of annoying, but I do have a least common or a greatest common factor between all these, right? 4, 14, and 16 or 6 can all be divided by 2. So I'm left with 2 times 2x squared minus 7x plus 3. This doesn't have an a of 1, which means I'm going to have to put a little bit more work in. And I want to do an X box in my window and actually get what this is factored. So a times c, 2 times 3 is 6. My middle term is negative 7. Negative 6 times negative 1 will give me negative 7. Actually, hold on. So now I'm good to make my window. Top left, I'm going to do the first term, 2x squared. Bottom right is my last c term, 3. And my new values I'm going to put in the top left. or bottom left and top right. So negative 6x and negative x. Greatest common factor between 2x squared and negative 6x is negative 2x. Negative 2x times negative x gives me 2x squared. Negative x times 1 gives me negative x. Negative 2x times 3 gives me negative 6x. And 3 times 1 gives me 3. I know I'm flying through this, but I think that hopefully we're okay with the windows by now. So my factored form is negative 2x plus 1 times negative x plus 3. All right, and now I'm going to rewrite my problem. So remember, I factored out a 2, so I still have a 2. And I have a negative 2x plus 1 and a negative x plus 3. All right, so guys, this subtraction problem, this expression we got here, my goal is to get a common denominator. All right, right now it's not looking great because I got a 6 and a 2, x minus 3 at negative 2x plus 1 and a negative x plus 3. So they don't really have anything too much in common, which is okay, but it's just kind of annoying. We can make it so they do have something in common though. Notice how close x minus 3 is with negative x plus 3. Very, very, very close, right? So we can change something. We can rewrite this. We'll keep this as 6 times x minus 3. And I can rewrite the denominator as negative 2 times positive 2x minus 1 times positive x minus 3. So I factored out a negative 1, and I can change that denominator to look like that. So to go from here to here, I factored out a negative 1, which changes the sign of every single term in that denominator. Why did I do that? Because look, now I can see that x minus 3 I share in the denominator, which it's just going to make me have a little bit of an easier time with this. So I need to find my least common multiple. That doesn't change. So in the denominator, my least common multiple is going to be 6 and negative 2. What do those have in common? They can both be multiplied to give you 6. Right? X minus 3, they both have. So that's the least common multiple is x minus 3. And then obviously we need to include that 2x minus 1. So that's got to be my new denominator. So I'm going to write these two fractions with the common denominators. Okay, so last thing we need to do is actually get the numerators correct then. If I were to rewrite the numerator, right, I multiplied the denominator. I have a 6x minus 3. Those stayed the same. But I multiplied a 2x minus 1 in. So I'm going to have to take 5 and multiply it by 2x minus 1. Notice that you can tell I didn't change the problem because I could cancel out the 2x minus 1 and make it a 1 if I wanted to. I'm going to leave it like this, but same thing up here, okay? So I have to multiply negative 2 times negative 3 to give me 6. So I'm going to have to do negative 3 times x minus 1. X minus 3 stayed, right? I have an x minus 3, the original and the end, so ignore that. And 2x minus 1 stayed. So I don't have to multiply by 2x minus 1. The only thing I had to multiply is the numerator by negative 3. Okay, now I want to keep going. I want to simplify this. So 5 times 2x minus 1 is 10x minus 5 minus, so I'm combining the fractions now, negative 3x plus 3 divided by 6x minus 3, 2x minus 1. So distributing the negative 3 and the 5 and then combining the fraction, I'm left with this. Simplifying this, I get 10x minus a negative 3x is plus 3x, which is 13x. Negative 5 minus 3 is negative 8, divided by 6 times x minus 3 times 2x minus 1. And finally, that's my answer. I think I did make an error at some point. Let me see where I made that error. And if you guys can spot it, let me know. It looks like somewhere I messed up. Let's see here. So let me know, guys, if you guys see any spot. So I got to figure out somewhere there was a sign issue. Like down here, 10x minus 5 was good, but this should be, it should be minus 3x. Huh. Oh, okay. I see you guys. Something little. Okay, the one difference is if you guys look here, I can rewrite this as 10x minus 5. If you look up here, it's really just plus 3 times x minus 1 because I have a minus a negative 3. So that turns into plus 3 times x minus 1, which is equal to, oh wait, hold on. Back up. Now I'm messing myself up. I apologize, guys. Minus. I'll tell you what, let's move on from this. I don't want to spend too much more time. I don't know exactly where my signs got messed up. But if you guys can, go ahead and let me know. So if you guys want to look over that, go ahead and let me know where I made my mistake. I'm going to keep looking at it. I'm going to let you guys work on another problem though. So go ahead, and we have about 8 minutes left. Try 3A. So let's look at the guided practice 3A. So I try to find where my mistake was. I'll let you guys do that. All right, guys, I found where my mistake was. Does anyone do this 3 Ed? Anyone get through that? So I know we kind of took a detour because I was trying to find where my mistake was, but I did figure that out. So I just want to make sure people are still listening and tuned in before I start explaining it so I'm not just talking to myself. So if you're interested in the mistake I made and also going over 3A, let me know in the chat. Okay, thank you, Sarah. Just want to make sure someone was still paying attention. Real quick, guys, for this one, I think you can still see. Back up here in this step, I took out a -1. I factored out a -1. Well, I factored out a -1 twice because I factored out a -1 from negative x plus 3 to get me there, and a -1 from -2x plus 1 to get me there. And if you factor out two -1s, -1 times -1 is +1. So this should have been a +2, not a -2, which meant that this was a +3, and that changed everything from there. So that fixes what I did. I apologize for that. Let's look at 3 capital A. So Digidio, at least you can check your work. I don't know if anyone else is still in here, but we have x minus 1 divided by x squared minus x minus 6 minus 4 divided by 5x plus 10. So first things first is we're going to factor. So I'm factoring the denominator, x squared minus 6. So what multiplies to -6 and adds to -1? That's going to be x minus 3 and x plus 2. And then I can factor out a 5 from 5x plus 10. Okay, I need my least common multiple between the denominators. So I see they both have an x plus 2 in there. 1 and a 5, the least common multiple is 5. They have an x minus 3. And like I said, they have that x plus 2. So my new denominator should be 5 times x minus 3 times x plus 2. All right, so for the first one, I have an x minus 3, I have an x plus 2, but I don't have a 5. So I have to multiply the denominator by 5, which means I have to multiply the numerator also by 5. For the next fraction, I have a 5 and I have an x plus 2, but I don't have an x minus 3. So I have to multiply the numerator by x minus 3. Distribute the 5 and distribute the 4. And then we still have our common denominator. So one big step for anyone who's still listening, and Digidio, I know you are, make sure you keep that minus in between. So the minus can throw things off. Make sure the minus you keep there, and then everything you put after it, put in parentheses. So if I distribute this 4, it's going to be 4 times x, which is 4x. 4 times -3 is -12. That all is being multiplied by -1. Or, if you don't want to do that, all right, good to know, Jaden, thank you. If you guys don't want to do it that way, you could also just make this a -4. So it'd be -4 times x, -4 times -3. However you want to look at it. Regardless how you look at it, you're going to be left with 5x minus 4x is x. -5 plus 12 is 7. And then the denominator is staying the same. So your final answer should be that. X plus 7 over 5 times x plus 2 times x minus 3. Again, I apologize for messing that up, guys. Just a little error there. All right. Any questions on that? And that ends the stream, guys, today. So hope you have all have a great day. I'll be on for my office hours, so if you do have any questions on this, or you want to go over another question from the book, whatever you want to do, I'll be here from 1 to 2. So please feel free to stop by. If not, I'll see you Wednesday. Khan Academy, go ahead and check that out now while it's fresh in your brain. 3 different assignments, so a total of 12 questions. Make sure you're writing them down because they will repeat themselves. All right, so hope you guys have a great day if I don't see you, and I'll be back on today, and then Wednesday we'll be live streaming again. Peace.